And for the last problem, the first three terms of the infinite geometric sequence, which are m minus 12, 9, and m plus 12, where m is an element of an integer. Write an expression for the common ratio. So for the common ratio, r equals it was second is to first or third is to the first. So either way, you can use 9 over m minus 12, or you can also have r where m plus 12 over 9. Okay, any of this. For letter number 2, hence show that this satisfies the equation m squared. Actually, this is wrong and the correction wasn't made. It should have been m minus 1 m squared minus 225. This is what we have to show equals 0. So I made an adjustment in the scoring. So if we have uh, using these two functions where r equals r, so we'll have 9 over m minus 12 equals m plus 12 over 9. This will give us 81 equals m minus 12 cross multiplication plus 12, which is equal to m squared. This is the square of um, the product of the sum and difference of binomials. So m minus 144. This is 81. So simplifying, you shall have m squared minus 144 minus 81 equals 0. This gives us m squared minus 225 equals 0. So we're already proven this part. For letter B, find two values of m. So two values of m, we already know that m squared minus 225 equals 0 is same as m plus 15 and m minus 15. That is finding the factors of squares of binomial. So we shall have m equals 15 and the other m equals negative 15. That's B1. B2, find the possible values of r. So you can just choose any in expression above in A. Let's say r equals 9. Let's say m equals 15. 15 minus 12 is 3 equals 3. Or let's say r and use negative 15, so we shall have 9 negative 15 minus negative 15 minus 12 is negative 27. So this gives us negative 1/3. So these are the two possible values of r, 3 and 1/3, negative 1/3. The sequence is a finite sum. State which value of r leads to this sum and justify it. Will have a finite sum when our r is negative 1/3 because the absolute value of r is less than 1, this always gives us a sum that is convergent. Sum is convergent, so it will be finite. If the sequence does not have a finite sum, find the sum of the first 4 terms. So it does not have a finite sum, then we shall use the formula. Let me use other colors so you can see where I put C2. Since it's not a finite sum, then we shall use the formula S sub n equals U sub 1 r raised to n minus 1 over r minus 1. And by substitution, so the first 4 terms should be 3 raised to 4 minus 1 over 3 minus 1. This gives us 3 times a over 2. So the sum is equal to 120. So if you have the first 4 terms, the sum will be 120.